been 2 years since NASA's James Webb Telescope gave us a stunning first look at the depths of our universe.
When we imagine life on other planets, we have to imagine that the environment on those planets will determine what the creature may look like.
Diamonds, the epitome of luxury and rarity on Earth, may be as common as pebbles on our neighboring planet, Mercury.
Could there be diamonds on Mercury? The latest image from the James Webb Telescope just changed everything we thought we knew. It showed us that even a simple-looking planet like Mercury could be packed with secrets, like craters full of potential diamonds. Right by the sun, this huge discovery hit our screens and proved our equipment was spot on. What other shocking secrets could Mercury be hiding? Let's dig deeper into these urgent mysteries. The first image we received from Mercury's orbit was breathtaking. As soon as it appeared on the screen, it matched exactly what we had been hoping to see. In that instant, we knew we had succeeded, and everything was functioning perfectly. NASA had just unveiled a remarkable deep space discovery right on this small planet. Despite appearing simple and being so close to the sun, Mercury hides dark and potentially valuable secrets beneath its surface, including craters that may harbor diamonds. But when we zoomed in closer, the room fell silent. In the shadow of a crater lay an unmistakable artificial structure, a secret Mercury was never intended to reveal. This small planet, once viewed as a mere faint dot in our telescopes, has become a source of fascination. Thanks to cutting-edge technology from the James Webb Telescope and other space missions, we've begun to unearth incredible findings. Some recent studies suggest that diamonds could exist deep in the planet's scorching environment. Yet that's not all. The core of Mercury is unusually large and puzzling, causing scientists to rethink what they know about planetary structures. For many years, we knew little about the landscape of Mercury, but new technologies have gradually begun to expose its mysteries. NASA's Mariner 10 mission in 1973 was a significant leap in studying the planet, followed by the Messenger mission in 2004. As Messenger orbited, it captured detailed images of a surface blanketed with craters and strange ridges, resembling those on our moon. These pictures revealed a dense, crater-filled planet with a surprisingly strong magnetic field and a larger-than-expected core, prompting scientists to reconsider their previous theories. 31 years after the Mariner 10 mission, the Messenger probe, designed to stay in orbit, gave us a clearer view of the planet. It gathered a massive amount of data, capturing over 200,000 images and revealing areas never seen before. Among its most intriguing findings were high concentrations of calcium and magnesium on the darker side. This discovery left scientists questioning how these elements could have accumulated there. On Earth, magnetic fields are generated by the movement of liquid iron within the core, but Mercury's unique internal structure produces different magnetic properties. During the day, surface temperatures can soar to 800 degrees Fahrenheit, hot enough to melt lead, while at night, they plummet to nearly -300 degrees Fahrenheit. This massive temperature fluctuation occurs because the planet's thin atmosphere cannot retain heat. Despite these extreme conditions, recent studies have identified some surprising surface features. In 2012, data from the Messenger mission indicated volcanic activity, including evidence of explosive eruptions, challenging the old belief that Mercury was geologically inactive. Scientists also discovered water ice in some of Mercury's polar craters. These craters are so cold that they can preserve ice, even though the planet is incredibly close to the sun. This finding raises additional intriguing questions, such as whether simple forms of life could exist on the planet, despite its harsh environment. Could life exist there? Though it sounds improbable, certain forms of life on Earth manage to survive in the most extreme conditions. So, it's not completely impossible that something could live there, even in Mercury's coldest, iciest regions. Currently, a mission named Bepi Colombo, launched in 2018 by the European Space Agency and the Japan Aerospace Exploration Agency, is en route to Mercury. This spacecraft is expected to reach the planet in 2025, providing us with an even closer look at its surface, chemical composition, and geological history. Typically, planets spin on their axis once per day and orbit the sun once a year. Mercury, however, defies these norms. It takes just 88 Earth days to complete an orbit around the sun, making its year quite short. Meanwhile, a single full rotation takes 176 Earth days, meaning that a day on Mercury lasts twice as long as its year. This odd timing results in strange effects on Mercury's surface. Imagine standing there, watching the sun rise, grow larger, then appear to stop, move backward slightly, and finally continue its path. This occurs because Mercury's slow rotation can't keep pace with its rapid orbit around the sun. Mercury's slow rotation is believed to be due to tidal locking, a gravitational influence from the sun that has gradually decelerated its spin over billions of years. Unlike Earth's moon, which is fully locked to Earth's rotation, Mercury has what's called a 3-to-2 spin-orbit resonance, meaning it rotates 3 times for every 2 orbits around the sun. This unusual spin-orbit relationship causes Mercury to experience extreme day-night cycles. One side remains facing the sun for a long time, becoming incredibly hot, while the other side stays in prolonged darkness and cold. Additionally, Mercury's atmosphere, called an exosphere, is incredibly thin and constantly lost to space, only to be replenished by sources such as solar wind, radioactive decay, and meteor impacts. In 2020, scientists were surprised to discover more water vapor in Mercury's exosphere than expected. This water likely forms from the interaction between hydrogen from the solar wind and oxygen in the planet's rocky surface. Mercury's long days and short years also affect its magnetic field in unexpected ways. Despite its small size and slow rotation, Mercury does have a magnetic field, a phenomenon scientists didn't anticipate. Research suggests the field is generated by a dynamo effect in its liquid metal core, influenced by its unique orbit and rotation. Though weaker than Earth's, this magnetic field plays a crucial role in protecting Mercury from the sun's solar wind, which could otherwise erode its thin atmosphere more quickly. Mercury's fast orbit and slow spin create some bizarre surface phenomena. There are regions known as hot poles, where the sun appears to freeze in place in the sky, creating the planet's hottest locations. Additionally, scientists have discovered water ice in the cold, dark craters near Mercury's poles, where sunlight never reaches. It's astonishing to find ice on a planet so near the sun, but these craters remain permanently in shadow, allowing the ice to stay frozen. These cold, frozen regions sharply contrast with the intense heat experienced on other parts of the planet. Recent studies have explored why Mercury spins so slowly. It appears the planet may have once spun much faster, but was gradually slowed down by the sun's gravity and impacts from large objects like asteroids. These findings provide scientists with new clues about Mercury's past and help us better understand how planets in our solar system evolve over time. Scientists are also intrigued by Mercury's large iron core, which constitutes about 85% of its volume, significantly larger than Earth's core, which accounts for only 15% of its volume. Experts like Dr. Nancy Chabot from Johns Hopkins Applied Physics Laboratory and Dr. Eric Asfog from the University of Arizona believe that Mercury was once a larger planet. They propose that a massive collision early in the solar system's history stripped away most of its outer layers. However, the most surprising discovery was that despite its small size and slow rotation, Mercury has a magnetic field. This magnetic field is only about 1% as strong as Earth's, as revealed by NASA's MESSENGER mission. This unexpected result challenges prior assumptions about magnetic fields on smaller planets. Dr. Katherine Johnson, a planetary scientist from the University of British Columbia, and her team continue to study these magnetic features to better understand Mercury's unique properties. These findings are pushing scientists to reconsider their understanding of planetary formation and evolution. The more we learn about Mercury, the more it challenges established views about the solar system. Mercury's magnetic field is also peculiar because it is not centered. Instead, it is offset by about 1/5 of the planet's radius. This unusual alignment may result from uneven thickness in the planet's crust, which could affect how heat is distributed within the planet. In 2020, scientists discovered elements like sulfur, potassium, and sodium on Mercury's surface. These elements would normally vaporize quickly under high heat, so their presence on a planet so close to the sun is surprising. Dr. Patrick Poplawski speculates that these elements may have been delivered by comets or asteroids after Mercury's formation. Another remarkable discovery is the presence of water ice in craters near Mercury's poles. These areas, which remain in permanent shadow, are cold enough to keep ice from melting. Dr. Nancy Chabot played a key role in this discovery, noting that the same craters also contain organic compounds, which could be similar to those that led to life on Earth. This suggests that Mercury may hold important clues about the origins of life in the solar system. But the surprises don't end there. For many years, scientists believed that Mercury was geologically inactive. However, data from the Messenger mission revealed signs of recent volcanic activity, including areas that appear to be volcanic vents. This indicates that Mercury is still an active planet. The planet's south pole adds another layer of mystery. It features a chaotic terrain of hills and valleys, some as large as Texas. Dr. Thomas Waters theorizes that powerful quakes, possibly caused by changes in Mercury's orbit due to the sun's gravity, may have created this rugged landscape. Further studies by Dr. Amir Khan, using data from the Messenger mission, revealed that Mercury has both a liquid outer core and a solid inner core, which is larger compared to Earth's. This unusual structure may help explain the planet's odd magnetic field. These discoveries continue to challenge our understanding of planetary formation and evolution, highlighting that there is still much to learn about our solar system as we delve deeper into Mercury's core and surface to uncover more of its secrets. Mercury, with a diameter of about 1,260 miles, has a core that makes up nearly half of its size. In comparison, Earth's inner core is only about 20% of the planet's total core. Despite Mercury's small size, it has a detectable magnetic field, although weaker than Earth's but still significant. Beneath its rocky surface, scientists have found that Mercury's mantle is much thinner than previously thought. Recent findings show that the mantle is only around 260 miles thick, compared to Earth's, which is approximately 1,800 miles thick, or 2,900 kilometers. This thin mantle influences how heat moves within the planet, affecting its geological activity. In 2012, an important discovery revealed shallow depressions on the planet's surface, known as hollows, suggesting past volcanic activity. These depressions formed when materials evaporated into space, indicating the presence of volatile elements on Mercury. However, a more surprising discovery came in 2020, when scientists analyzed more data from the Messenger mission and found a massive ancient magma reservoir buried beneath Mercury's crust. This reservoir likely played a key role in shaping the planet's landscape and may explain features like the northern volcanic plains, which formed from lava flows in Mercury's early history. In 2022, another fascinating discovery revealed nitrogen trapped beneath Mercury's surface. This nitrogen may be a remnant of an ancient atmosphere, forced underground by intense solar radiation and heat. This finding raises intriguing questions about what the planet's past climate might have been like, and whether it was once more hospitable. There's even more to the story. Craters hidden from direct sunlight contain ice, likely deposited by comets or asteroids that crashed into the planet in recent millennia. These craters may also hold dark materials, possibly organic compounds delivered in the same manner. The presence of these materials provides a rare chance to study how organic compounds are distributed across the solar system. Mercury's surface reveals a long and complex history and notable differences from Earth, such as the lack of plate tectonics. Even without tectonic activity, Mercury is shrinking as it cools, creating numerous cracks and faults. These features offer insight into the planet's intriguing geological past. In some areas, large cracks expose deeper layers, giving scientists additional clues about its evolution. In 2019, researchers found evidence that Mercury's surface might still be changing. They discovered small valleys called grabens near larger cracks formed by ground stretching. Their recent formation suggests that Mercury's surface continues to evolve. Another interesting aspect is Mercury's magnetic field, which differs from Earth's. While Earth's magnetic field is generated by molten iron in the outer core, Mercury's may result from a liquid metal layer around its solid core, acting like a dynamo. There are also speculations about cracks beneath the crust that might allow heat or even liquids to move. Though Mercury's surface appears lifeless, some scientists believe there could be pockets of water deep below, kept from freezing by residual heat. This isn't as far-fetched as it may seem, given similar findings on celestial bodies like Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, both of which have oceans beneath their icy exteriors. Therefore, water beneath Mercury's dry surface remains a possibility. Exploring these hidden regions ignites our curiosity and expands our understanding of the ongoing processes shaping Mercury. Here's something to think about. This knowledge could help us learn more about geological activities on other planets and moons too. Mercury then becomes a crucial piece of a larger puzzle, helping us explore the solar system and learn how it has changed over time. But don't forget, this story isn't over yet. Mercury continues to surprise us, and with every new discovery, we get closer to unraveling the mysteries of our universe. How has Mercury evolved internally over time? What unknown materials might be buried beneath its surface? And what could they reveal about the early days of the solar system and the formation of planets? These questions highlight why it's vital to keep studying Mercury. Every new discovery about what's hidden beneath the surface offers insights into how all planets form and evolve in our solar system. As scientists consider future space missions, they're eager to see what they might uncover. Although Mercury is small and close to the Sun, it still holds many secrets. By studying these details, we can learn not only about Mercury, but about other planets in our solar system and beyond. Mercury could help us understand how planets survive in extreme environments near their stars and remain stable for billions of years. As scientists continue to send probes and gather data, every new discovery could reshape our knowledge of space. With its intense heat and proximity to the Sun, Mercury is an ideal place to test our ideas about how planets form and develop. The more we discover, the more questions arise, which fuels our curiosity and pushes us to explore Mercury and other planets even further. Though it's one of our closest neighbors, there's still so much we don't know about Mercury. Questions remain about its surface, core, and the processes happening inside. Scientists believe that by studying it more closely, we can learn not only about Mercury's story, but also about the early history of other planets, including Earth. Each new discovery might give us clues about how planets in our solar system, and even those in other star systems, are born and change over time. Mercury's harsh conditions, its extreme heat, cold and thin atmosphere, make it a perfect testing ground for theories about how planets form and survive. Scientists want to know how such a small planet can endure being so close to the Sun for billions of years without being destroyed. Could unique materials inside Mercury help it survive these extreme conditions? And if so, could these materials exist on other planets in distant star systems? Every mission to Mercury has the potential to revolutionize our understanding of the universe. Probes and spacecraft allow us to study Mercury's surface, atmosphere, and internal activity. As we develop more advanced tools and technology, our ability to explore Mercury improves. Each new mission could help solve more of Mercury's mysteries and deepen our knowledge of the universe we inhabit. Could Mercury be the key to finding life elsewhere in the cosmos? Like, comment, and subscribe for more.
It has been 2 years since NASA's James Webb Telescope gave us a stunning first look at the depths of our universe. The $10 billion telescope is the largest and most powerful in...
It's just Mercury does it more often than the others, so there's more occasion to speak of this happening with Mercury.
Due to the fact that Mercury is the fastest planet in the solar system, the symbol is the man with the wings, and as Mercury bypasses and swings by the Earth, it appears
close to the Sun. A tiny planet hides big secrets. Mercury, small and hot, fooled us for years. But now, space robots have uncovered strange surprises. They claim to have found diamonds on this scorching planet. And that's just the beginning. Mercury's insides are unusual, too large and too strange. Why is it so different from other planets? And what else is Mercury hiding? Mercury, the smallest planet in our solar system, has fascinated astronomers and space enthusiasts for ages. Its mysterious landscape, hidden for centuries, began to reveal its secrets only when space exploration advanced. The journey to uncover Mercury's mysteries started with NASA's Mariner 10 mission in 1973 and continued with the Messenger probe in 2004. Mariner 10, the first spacecraft to visit Mercury, gave us our initial close-up view of this elusive world. Its flybys revealed a landscape filled with craters and ridges, much like our moon. This mission showed that Mercury had a rough, heavily cratered exterior, a surprisingly strong magnetic field, and a larger-than-expected core. These findings challenged previous assumptions about Mercury's composition. The Messenger mission, Mercury surface, space environment, geochemistry and ranging, launched 31 years after Mariner 10, deepened our understanding of Mercury. Unlike its predecessor, Messenger entered orbit around Mercury, allowing a more comprehensive study. During its mission, Messenger captured 200,000 photographs, revealing areas of Mercury never seen before. One of Messenger's most intriguing findings was the discovery of unusually high levels of calcium and magnesium on Mercury's darker side. This raised questions about the processes that led to such concentrations. Additionally, the mission found Mercury's magnetic field unusually strong in the northern regions, which was unexpected. These discoveries led scientists to realize that Mercury's internal structure and formation were quite different from what was initially thought. Unlike Earth, where magnetic fields are generated by liquid iron in the core, Mercury's unique internal structure results in different magnetic behavior. But Mercury's terrain is striking not just because of its craters and ridges, but also due to its extreme surface conditions. During the day, temperatures on Mercury soar to 430 degrees Celsius, 806 degrees Fahrenheit, hot enough to melt lead, while at night they drop to a frigid minus 180 degrees Celsius, minus 292 degrees Fahrenheit. This drastic temperature swing is due to Mercury's thin exosphere, which doesn't retain heat. Despite these harsh conditions, recent studies have revealed surprising features on Mercury's surface. In 2012, MESSENGER data showed evidence of volcanic activity, including pyroclastic deposits from explosive volcanism, challenging the belief that Mercury was geologically dead. Even more intriguing, in 2020, scientists discovered water ice in some of Mercury's polar craters. These permanently shadowed regions are cold enough to preserve ice, even on a planet so close to the Sun. This finding raises new questions about the potential for simple forms of life on Mercury. Could extremophiles, similar to those on Earth, be living in these icy refugees? The most recent mission to Mercury, Bepi Colombo, launched in 2018 as a joint effort between the European Space Agency and Japan Aerospace Exploration Agency, is set to arrive at Mercury in 2025. This mission promises to provide even more detailed information about Mercury's surface, including its chemical composition and geological history. From its unexpectedly strong magnetic field to the presence of water ice, Mercury continues to surprise us. But what we're about to explore next will really make you do a double take. How does a planet so close to the Sun have a year shorter than its day? A year shorter than a day. When we think about planets, we usually imagine them spinning on their axis once a day and orbiting the Sun over a year. But Mercury breaks this mold in a fascinating way. On this sun-scorched world, a year is actually shorter than a day. Mercury takes just 88 Earth days to orbit the Sun, making its year much shorter than ours. Yet a single day on Mercury, one full rotation, takes 176 Earth days, meaning a year is only half as long as a day. This unusual situation creates bizarre effects. If you stood on Mercury's surface, you'd see the Sun rise, grow larger, then appear to stop, move backward, and resume its path. This strange dance occurs because Mercury's rotation can't keep up with its rapid orbit. Mercury's slow rotation is likely due to tidal locking. Over billions of years, the Sun's gravity has slowed Mercury's spin. However, unlike our Moon, Mercury is in a 3-2 spin-orbit resonance, rotating 3 times for every 2 orbits around the Sun. The extreme day-night cycle leads to severe temperature variations. The side facing the Sun bakes for months, while the night side freezes. Mercury's thin exosphere, a very sparse atmosphere, does little to moderate these extremes. This exosphere, constantly replenished by solar wind, radioactive decay, and micrometeorite impacts, was found in 2020 to contain more water vapor than expected, possibly formed by solar wind interactions with surface rocks. Mercury's short year and long day also impact its magnetic field. Despite its small size and slow rotation, Mercury has a global magnetic field, likely generated by a unique dynamo effect in its liquid metal core, driven by its peculiar orbit and rotation. This magnetic field, although weaker than Earth's, protects Mercury's surface from solar wind, preventing the rapid loss of its thin atmosphere. Mercury's rapid orbit and slow rotation create intriguing observational possibilities. At certain points called hot poles, the Sun appears stationary in the sky, subjecting these regions to extreme heat. Conversely, near Mercury's poles are permanently shadowed areas where ice persists despite the planet's proximity to the Sun. The cold, shadowed craters keep this ice intact, raising the possibility of other preserved volatile substances like organic compounds. Mercury's unusual orbit and rotation also pose challenges for spacecraft. Missions must perform complex maneuvers using planetary flybys to slow down enough to enter Mercury's orbit. The Bepi Colombo mission, launched in 2018, is currently en route, using such techniques, and will arrive in 2025. It will face the additional challenge of balancing exposure to Mercury's extreme heat and cold due to its day-night cycle. Recent simulations suggest Mercury's slow rotation may be the result of gravitational effects from the Sun and impacts from large asteroids or comets, which slowed it over time. This research not only sheds light on Mercury's history, but also on the evolution of other planets in the solar system. As we continue to study Mercury, questions persist. How does its core stay partially liquid despite the extreme cold? How does its orbit shape its geology? Mercury's unique features challenge our understanding of planetary formation, urging us to explore new theories. What other secrets might Mercury be hiding beneath its cratered surface? A small planet with too many intense secrets. Mercury, the smallest planet in our solar system, is filled with mysteries that continue to baffle scientists. Despite its size, Mercury reveals surprising and unique characteristics. One of its most intriguing features is its unusually large core, which constitutes about 85% of the planet's volume, far greater than Earth's 15%. Dr. Nancy Chabot's study suggests this massive core could result from a massive collision early in the solar system's history, stripping Mercury of its outer layers and leaving behind an iron-rich core. Mercury's magnetic field is another enigma. Unlike Venus and Mars, Mercury has a global magnetic field, about 1% as strong as Earth's. This unexpected discovery, made by NASA's Messenger mission, puzzled scientists because they didn't anticipate such a small, slowly rotating planet to maintain a magnetic dynamo. Dr. Katherine Johnson's team found that the field is offset from the planet's center by about 20% of its radius, possibly due to variations in crust thickness that affect heat flow. In 2020, scientists discovered volatile elements like sulfur, potassium, and sodium on Mercury's surface, elements that usually evaporate quickly at high temperatures. Dr. Patrick Poplawski suggested these volatiles might have been delivered by comets or asteroids after the planet formed. Additionally, water ice was found in permanently shadowed craters near Mercury's poles, despite the planet's proximity to the Sun. This ice, along with organic compounds found in the same craters, hints at the possibility of clues to life's origins in the solar system. Mercury's geological activity also challenges previous assumptions. Messenger data revealed recent volcanic activity, with small, bright spots identified as volcanic vents by Dr. David Rothery. These hollows suggest that Mercury might still be geologically active. The chaotic terrain near Mercury's south pole, covering an area the size of Texas, was likely formed by massive earthquakes caused by the Sun's tidal forces as the planet's orbit evolved, according to Dr. Thomas Waters. Recent studies by Dr. Amir Khan have shown that Mercury's core likely has a liquid outer layer and a solid inner core, similar to Earth's, but proportionally much larger. This might explain some of the planet's unique magnetic properties. These discoveries challenge our understanding of planetary formation and evolution, leaving us to wonder what other surprises Mercury may hold beneath its cratered surface. Mercury's hidden depths. Recent discoveries and ongoing missions are revealing that Mercury's subsurface holds secrets just as fascinating as its visible features. One of the most intriguing aspects of Mercury's hidden depths is its core structure. Unlike Earth's solid inner core surrounded by a liquid outer core, Mercury's core is mostly liquid with a solid inner portion. NASA's Messenger mission confirmed this unusual composition by mapping Mercury's internal structure using gravitational field variations. Mercury's solid inner core, approximately 1,260 miles, 2,000 kilometers, wide, makes up nearly half of the planet's core, significantly larger proportionally than Earth's. This core size and state are crucial for generating Mercury's surprisingly strong magnetic field, despite being weaker than Earth's. Beneath Mercury's crust lies a mantle thinner than previously thought, only about 260 miles, 420 kilometers, thick, compared to Earth's 800-mile thick mantle. This thin mantle affects Mercury's geological activity and heat distribution. A major discovery in 2012 revealed ancient volcanic activity on Mercury. Messenger detected shallow depressions called hollows, formed by the sublimation of volatile elements, indicating that Mercury's interior once contained more volatiles than expected. In 2020, researchers found evidence of an ancient magma ocean beneath Mercury's surface, likely responsible for shaping its unique surface features, such as the vast, smooth plains in its northern hemisphere. In 2022, another groundbreaking discovery revealed nitrogen trapped beneath Mercury's surface, potentially remnants of an ancient atmosphere driven underground by intense solar radiation. This raises questions about Mercury's past atmosphere and its implications for early climate and habitability. Mercury's hidden depths also contain water ice in permanently shadowed polar craters, shielded from sunlight by extreme cold. Some of this ice may be relatively fresh, possibly delivered by comets or asteroids within the last tens of millions of years. Alongside the ice, dark deposits believed to be organic compounds offer a rare opportunity to study the distribution of these materials in the inner solar system. Mercury's subsurface provides clues to its tectonic history, showing significant contraction over time, resulting in thrust faults that reveal the planet's geological past. Recent analysis suggests that Mercury may still be tectonically active, with young landforms called grabens, indicating ongoing crustal shifting. One of the most mysterious features of Mercury's subsurface is its magnetic field. Unlike Earth's, which is generated by molten iron motion, Mercury's magnetic field may be produced by a dynamo effect in a thin outer layer of liquid metal surrounding its solid inner core. Additionally, the possibility of subsurface faults and fractures raises the intriguing idea that pockets of liquid water might exist deep beneath Mercury's surface, kept warm by residual heat from the core. While the idea of subsurface water on Mercury seems far-fetched, similar phenomena have been observed on other worlds like Europa and Enceladus. As we explore Mercury's hidden depths, new questions arise. How has Mercury's internal structure evolved? Could volatile elements or compounds be trapped beneath the surface? What can Mercury's subsurface tell us about the early solar system and the formation of inner planets? Continued exploration of Mercury is crucial for enhancing our understanding of this fascinating world and planetary formation. Despite its small size and proximity to the Sun, Mercury still holds many secrets. Its hidden depths may offer clues to its past and the history of our solar system. What do you think we might find on Mercury in the near future? Could it be precious stones or even signs of extraterrestrial life? If you enjoyed this video, don't forget to smash that like button and subscribe to the channel so you never miss any updates. Thanks for watching, and we'll see you in the next one.
We have Caroline Smith-Fix. She's head of research sciences collections at the Natural History Museum in London. Okay, so news from Mars. Not just that water was there.
Was a perfect 10 on the red planet. But that's just the first step of many steps to come. Next, we want to go to perhaps the polar ice caps, or perhaps even drill underground.
Then, if life happened here on Earth, why couldn't it happen elsewhere? If we find life on Mars, that would transform biology.
13 years ago, NASA deployed the Curiosity rover on Mars, and then 3 years ago they sent another rover, Perseverance, to join the mission. These rovers were sent to map the planet and study its surface. And now finally, they have sent back some super incredible footage that is simply mind-blowing. So what exactly are we seeing here? And what else have these rovers been up to since they touched down on the red planet? The first Mars exploration. Our fascination with Mars, the red planet, has existed for centuries, but it was the space age that allowed us to take a closer look. The first successful mission was NASA's Mariner 4 in 1964, a flyby that sent back the first close-up photos, revealing Mars's cratered, moon-like surface. This milestone fueled our curiosity and desire to learn more about our neighboring planet. In the following years, several more missions were launched. The Viking missions in the 1970s were especially significant. Viking 1 and Viking 2 both landed on Mars, conducting experiments to search for life. Although they didn't find definitive evidence, they provided extensive data on Mars's soil, atmosphere, and weather. Mars exploration has advanced considerably since those early missions, with each new mission building on past successes. The Mars Pathfinder mission in the 1990s delivered the Sojourner rover, a small six-wheeled rover that could move around and analyze rocks and soil. This was a major breakthrough, showing that we could land on Mars and explore its surface. The 2000s saw even more ambitious missions. The Mars Global Surveyor mapped the planet in detail, while the 2001 Mars Odyssey mission discovered significant amounts of hydrogen just below the surface, suggesting the presence of water ice. These findings hinted at the possibility of life on Mars and supported the idea that humans might one day live there. But why focus on Mars? Unlike Venus or Mercury, Mars is the most Earth-like planet in our solar system, with seasons, polar ice caps, and weather patterns. Studying Mars helps us understand more about Earth's history and potential future. Additionally, as Earth faces challenges like climate change and overpopulation, Mars offers a potential second home for humanity. However, to consider colonization, we need a deeper understanding of Mars, which is where these missions come in. NASA's rover missions have been central to Mars exploration, with robotic scientists equipped to study the Martian surface and environment. The Sojourner rover from the Mars Pathfinder mission was the first, followed by the twin rovers Spirit and Opportunity, which landed in 2004. Although designed to last 90 days, they explored for years, with Spirit investigating Gusev Crater and Opportunity discovering evidence of past water activity in Meridiani Planum. These successes led NASA to develop even more advanced rovers, pushing the boundaries of our knowledge and seeking answers to new questions about Mars. So what new rovers did they create after Spirit and Opportunity? The Curiosity rover. NASA's first next-generation rover sent to Mars was Curiosity. Launched on November 26, 2011, as part of the Mars Science Laboratory mission, Curiosity landed in Gale Crater on August 6, 2012, after a 9-month journey. The crater was chosen because scientists believed it might have once had water and possibly life. The descent, famously called the 7 Minutes of Terror, involved a risky sky crane maneuver, which had never been tried before. Despite the tension, the landing was successful, and Curiosity sent back its first images, marking a new era in Mars exploration. Curiosity is about the size of a car, measuring 10 feet long, 9 feet wide, and 7 feet tall, and weighing nearly 2,000 pounds. It is equipped with advanced tools like the ChemCam, which uses a laser to vaporize rocks and soil for analysis, and SAM, Sample Analysis at Mars, a mini-lab that can examine samples for organic compounds, crucial for determining if life ever existed on Mars. The rover is powered by a radioisotope thermoelectric generator, RTG, which converts heat from the decay of plutonium-238 into electricity, allowing it to operate day and night through all seasons. The entire Mars Science Laboratory mission, including Curiosity, cost about $2.5 billion. Despite the high cost, the mission has provided invaluable information about Mars, making it a worthwhile investment. The name Curiosity was chosen through a NASA-sponsored essay contest in 2009, won by Clara Ma, a 6th grader from Kansas. In her essay, Clara described Curiosity as an everlasting flame that burns in everyone's mind, capturing the spirit of exploration. NASA found her words inspiring and fitting for the rover, emphasizing that exploration is for everyone. So, with all this investment in technology, what has Curiosity discovered on Mars? The discoveries by Curiosity. Curiosity's mission on Mars has been truly remarkable, making discoveries that have significantly advanced our understanding of the red planet. For instance, Curiosity detected organic compounds in rock samples from Gale Crater. These organic molecules, which contain carbon, could serve as building blocks and food for life. This discovery is crucial because it suggests that Mars might have once supported life, even if it never did. The isotopes in carbon dioxide and methane found by Curiosity could be consistent with ancient biological activity, though they might also result from non-life processes, like sunlight interacting with carbon dioxide in Mars' atmosphere. This finding drives ongoing and future studies to search for signs of life on Mars and beyond. Curiosity also observed fluctuations in methane levels in Mars' near-surface atmosphere. While most methane on Earth comes from biological processes, we don't know if that's true for Mars. Although Curiosity can't confirm whether the methane it detected is from biological sources, it hints at the possibility of biological activity on Mars. Another key mission of Curiosity was to determine the formation and exposure age of rocks on Mars. The rocks around Gale Crater formed about 4 billion years ago, later becoming sedimentary rocks in Yellowknife Bay. About 70 million years ago, these rocks were exposed to surface radiation due to weathering and erosion. This helps scientists understand Mars's erosion rates and how radiation might affect organic compounds, which is crucial for identifying potential biosignatures. Curiosity also revealed Mars' watery past. The presence of jarosite, a mineral that forms only in watery environments, suggests that water once existed on Mars. An age-dating experiment found jarosite younger than expected, implying that liquid water might have persisted below the surface even as the planet dried out. This indicates that Mars may have had habitable conditions for longer than previously thought. In addition, Curiosity showed how Mars lost its atmosphere and transitioned from a warm, wet planet to the cold, dry one we see today. By measuring the ratio of deuterium to hydrogen in water samples, Curiosity provided evidence of hydrogen escape and water loss over time, helping scientists understand Mars's long-term climate changes. Curiosity also detected biologically useful nitrogen in the form of nitrate in rock samples, which was surprising. On Earth, nitrogen is essential for life, but it needs to be in a fixed form to be usable. The discovery of fixed nitrogen on Mars suggests that usable nitrogen was present 3.5 billion years ago, possibly sustaining Martian life forms. Due to these compelling findings, NASA extended Curiosity's mission at least into 2025. However, Mars is vast, and a single rover can't explore it all, leading NASA to launch a second rover. How was this new rover different from Curiosity? The Perseverance rover. After Curiosity, NASA launched the Perseverance rover to Mars on July 30th, 2020, landing it in Jezero Crater on February 18th, 2021. This site was chosen because it's believed to have been an ancient river delta and lake, making it ideal for searching for signs of past life. The landing was a nail-biting event as Perseverance entered Mars's atmosphere at 12,000 miles per hour, enduring the 7 minutes of terror. It autonomously slowed down, deployed a parachute, and used a sky crane maneuver to gently touch down on the Martian surface. The complex sequence had to be performed without real-time communication due to the distance from Earth, but everything went smoothly. Perseverance, similar in size to Curiosity, includes significant upgrades. It is equipped with advanced scientific instruments, including the Mars Oxygen In Situ Resource Utilization Experiment, MOXIE, which you'll learn about shortly. The rover also has 19 cameras, the most ever sent to Mars, to capture high-definition images and videos, aiding scientists in studying the planet's geology and searching for ancient microbial life. It carries a drill to collect rock and soil samples, which will be stored for potential return to Earth. Its redesigned wheels offer better durability and traction, essential for navigating Mars' rough terrain. Like Curiosity, Perseverance is powered by a radioisotope thermoelectric generator, converting heat from plutonium-238 decay into electricity, allowing continuous operation through all seasons. The name Perseverance was chosen through a Name the Rover essay contest held by NASA in 2019. 7th grader Alexander Mather proposed the name, reflecting humanity's enduring challenges and determination, which NASA felt perfectly captured the mission's spirit. Nicknamed Percy, the rover was sent with a special companion, the Ingenuity helicopter. But why a helicopter when it already had 19 cameras? Stay tuned to find out. The Ingenuity helicopter. Ingenuity arrived on Mars on February 18, 2021, attached to the underside of the Perseverance rover. It was a great experiment. The scientists wanted to see if we could actually fly a helicopter on Mars, where the atmosphere is just 1% as dense as Earth's. Initially, Ingenuity was only supposed to make 5 flights over 30 sols, which are Martian days. These test flights were designed to prove that controlled flight in Mars's thin atmosphere was possible. Each flight lasted up to 90 seconds, reaching altitudes between 10 to 16 feet. But Ingenuity far exceeded expectations. After successfully completing its initial 5 flights, NASA's Jet Propulsion Laboratory devised a series of operational flights to see how this tiny helicopter could assist in exploring Mars. Ingenuity began scouting areas of interest for Perseverance. It improved navigational techniques and tested the limits of its flight capabilities. This aerial scouting provided valuable information that ground-based rovers alone could not easily obtain, like the best paths to travel or interesting geological features to investigate. The technology behind Ingenuity is quite remarkable. It weighs just 4 pounds and features counter-rotating blades that spin at about 2,400 revolutions per minute, much faster than helicopters on Earth due to the thin Martian atmosphere. Ingenuity also has solar panels to recharge its batteries, which allow it to operate independently. It is also equipped with a navigation camera and a communication system to relay data back to Perseverance, which then sends it to Earth. Over nearly 3 years, Ingenuity completed 72 flights, far surpassing its initial goal. It flew for a total of 2 hours, 8 minutes, and 48 seconds over 1,004 Martian days, covering more than 17 kilometers. This performance in the harsh conditions of Mars demonstrated not only its resilience, but also the feasibility of using aerial scouts for planetary exploration. However, on January 18, 2024, during its 72nd flight, Ingenuity's rotor blades were damaged while landing, grounding the helicopter permanently. NASA announced the end of its mission a week later. Despite this, Ingenuity made so many incredible discoveries with Perseverance. What did they find together on the surface of Mars? The discoveries by Perseverance. When Perseverance was set to land in Jezero crater, scientists were unsure about the types of rocks they would encounter. Some expected ancient lava flows, while others thought the rocks might be sedimentary, carried by wind or water. During its first year, Perseverance made a surprising discovery. It found various igneous rocks, including lava flows and those crystallized from slow-cooling magma. These rocks contain crystals that reveal their formation history and show signs of water interaction, suggesting conditions that could have supported microbial life. If these samples are returned to Earth, they could offer insights into Mars's interior, volcanic history, and the age of Jezero's geological formations. On February 16, 2022, Perseverance captured a panoramic view of an area called Santa Cruz, providing a detailed look at Jezero crater's boulders and landscape. Later, at Wildcat Ridge within the crater's sedimentary fan deposit, Perseverance found evidence of an ancient lake environment. These sediments, likely deposited in standing water, continued to interact with water long after their formation, making them ideal for preserving potential signs of ancient life. Perseverance also uncovered a more complex water history in Jezero crater than previously thought. While scientists knew a lake once filled the crater, new images revealed sediments deposited in a delta, indicating a dynamic water history. The rover also found signs of high-energy flooding that carried large boulders into the crater, though the origin of these floods remains unknown. In addition to geological discoveries, Perseverance achieved a technological milestone with MOXIE, which produced oxygen from Mars's carbon dioxide atmosphere for the first time. Over 16 runs, MOXIE generated about 4 ounces, 122 grams of oxygen, enough to support an astronaut for roughly 4 hours. This success means we can produce oxygen on Mars. MOXIE completed its final run in September 2023, after 2 years of operation. Another fascinating achievement was recording sounds on Mars. Perseverance's microphones captured the Martian environment, including wind and the operation of its tools. These recordings revealed that sound travels slower on Mars due to the thin atmosphere, and the volume of sounds changes with atmospheric pressure. During low-pressure seasons, almost complete silence was recorded. Sounds are quieter and more muffled on Mars, and high-pitched noises are harder to hear. This analysis provides new insights into Mars's atmospheric dynamics and seasonal changes. Perseverance wasn't alone in making these discoveries. The Ingenuity helicopter also played a key role. Both rovers have sent back incredible evidence to Earth, including stunning 4K videos. The first 360-degree view was captured by Curiosity, and the last panoramic view was recorded by Perseverance from Ingenuity's final airfield. Beyond these ongoing operations, what does NASA have planned for the future? Upcoming missions. As we look to the future of Mars exploration, there's much to be excited about. NASA's rovers, currently exploring the Red Planet, are collecting samples that scientists hope will reveal clues about Mars's ancient history and potential for past life. However, these samples won't return to Earth until 2033 at the earliest, as part of NASA's Mars Sample Return Program. This ambitious program involves several steps to safely bring the samples collected by Perseverance and Curiosity back to Earth. A lander will retrieve the samples from the rovers, launch them into Mars orbit, where they will meet up with an orbiter that will carry them home. This mission is crucial, as it will allow scientists to analyze Martian samples with advanced tools on Earth. While the samples journey back to Earth, the rovers will remain on Mars. Curiosity, which has already made significant discoveries about the planet's habitability, will continue its mission alongside Perseverance. Both rovers will keep exploring and conducting experiments on the Martian surface, but collecting samples is just one goal. There's a bigger vision: living on Mars. NASA is rapidly advancing plans to send humans to Mars, and they aren't alone. Elon Musk, the founder of SpaceX, has ambitious plans to colonize Mars, envisioning self-sustaining colonies. SpaceX is developing the Starship spacecraft, designed to transport humans and cargo to Mars and beyond. Starship is reusable and can carry many people, making it central to Musk's vision of building a human settlement on Mars. Musk also has ideas for creating habitats on Mars, using local resources to produce water, oxygen, and building materials, aiming for a self-sustaining environment where humans can live without relying on Earth. NASA and SpaceX are collaborating on several projects, including developing technology for human missions to Mars. Mars exploration is moving quickly, with both NASA and SpaceX aiming to eventually colonize the red planet. This involves creating the technology and infrastructure needed for long-term human habitation. Would you like to live on Mars? Do you think it will ever be possible? Let us know in the comments below. For more mysteries uncovered, like this video and subscribe to the channel. Thanks for watching and goodbye.
Concerns over a potential volcanic eruption are rising in Italy after hundreds of tremors were felt west of Naples in recent weeks.
Imagine a volcanic eruption in Europe so massive it alters our planet's climate. What would be the consequences? Let's take a journey into the world of geology and explore the concept of supervolcanoes. Picture a volcano so enormous, so powerful, that its eruption could have a global impact. These are not your typical volcanoes. These are supervolcanoes, and their eruptions are on a scale that's hard to comprehend. As we delve into this topic, we're met with a sobering realization. These supervolcanoes are not confined to some distant, uninhabited corner of the world. In fact, one such giant slumbers right in the heart of Europe. But what would happen if this giant were to wake from its slumber? What would be the aftermath of such an overwhelming natural event? The answer, quite simply, is change. A change in climate, a change in landscapes, a change in the very fabric of life as we know it. A supervolcanic eruption could plunge the world into a volcanic winter, disrupting agriculture and causing food shortages. It could alter landscapes, burying entire cities under ash and changing the course of rivers. It could affect the health of millions, not only from the immediate dangers of the eruption, but also from the long-term impact of inhaling volcanic ash. And yet, despite the potential calamity, there is a captivating allure to these sleeping giants. They are a testament to the raw, untamed power of nature. They remind us of our planet's dynamic nature, its ability to change and evolve over time. So, is Europe on the brink of such a cataclysmic event? Is there a supervolcano ticking like a time bomb beneath our feet? One such sleeping giant lies beneath the vibrant city of Naples, Italy. It's called Campi Flegrei. The history of Campi Flegrei, or the Phlegraean Fields, is no ordinary volcano. This sleeping giant, located just west of Naples, has a history both fascinating and fearsome. Its name, translating to burning fields, is a testament to the ancient Romans' encounters with this volatile land. The history of Campi Flegrei is punctuated with eruptions, but none as significant as the Campanian Ignimbrite eruption. This event, which took place around 39,000 years ago, is one of the largest volcanic eruptions in European history. The scale of the eruption was so vast, it's said to have covered much of the Mediterranean area in a blanket of ash, causing a volcanic winter and a significant drop in global temperatures. But what made this eruption particularly devastating was its impact on the environment and life at the time. The ash and gases released into the atmosphere caused a dramatic climate shift, leading to the extinction of several species. Some researchers even suggest this event played a role in the decline of the Neanderthals. Campi Flegrei's eruptions have not always been on this scale though. Its last eruption, in the year 1538, was much smaller, forming a new mountain, Monte Nuovo. This event, however, was enough to remind us of the potential power lurking beneath the surface. Over the years, this supervolcano has been relatively quiet, with only sporadic periods of unrest. But beneath this apparent tranquility, magma continues to accumulate, causing the ground above to rise and fall in a phenomenon known as bradysism. The question that looms now is, when will Campi Flegrei awaken again? And if it does, will it unleash an eruption to rival that of its ancient past? As we delve deeper into the history and potential future of this formidable volcano, we are reminded of the delicate balance that exists between our planet's geological forces and the life that inhabits it. The threat of Campi Flegrei. The clock is ticking for Campi Flegrei, and the threat it poses is far from hypothetical. This supervolcano, nestled on the western edge of Naples, is stirring. Recent seismic activities have been reported, with tremors reaching up to a magnitude of 4.2 on the Richter scale. The the strongest in 4 decades. This has led to growing concern among volcanologists who are closely monitoring the situation. This is not a simple case of the Earth stretching its limbs. Rather, these tremors are thought to be caused by magma pushing up into the subsurface of the volcano, a sign that Campi Flegrei could be awakening from its long slumber. These seismic activities could potentially lead to another major eruption, an event that would undoubtedly have catastrophic consequences. The last time Campi Flegrei erupted, it was the Campanian Ignimbrite eruption around 39,000 years ago. That eruption had widespread environmental impacts and changed the course of history. Today, a similar eruption could spell disaster on an unimaginable scale. The economic, geographical, environmental, and human implications would be significant. To put it into perspective, the recent eruption of Mount Etna, Europe's most active volcano, led to the evacuation of over 36,000 people in the northern regions of Italy. Now, imagine the impact of a supervolcano like Campi Flegrei erupting. The potential damage and loss of life would be far greater. Efforts are underway to understand and monitor the volcano's behavior. The Campi Flegrei Deep Drilling Project, for instance, aims to study the volcano's past in order to predict its future. These efforts are crucial in preparing for a potential eruption and setting up early warning systems. Yet the unpredictability of this volcanic system makes it a daunting challenge for scientists and authorities alike. The Campi Flegrei Deep Drilling Project. In the face of this imminent threat, scientists are not sitting idle. They have taken the fight underground, quite literally, with the Campi Flegrei Deep Drilling Project. This ambitious endeavor is aimed at peering into the fiery belly of the beast, seeking to unravel the mysteries of this complex volcanic system. The project involves drilling deep into the heart of the Campi Flegrei caldera, a massive volcanic crater, to collect rock samples and gather data. The objective of this daring mission: to better understand the volcano's behavior, predict its future activity, and ultimately protect the lives of those living in its shadow. Through this project, scientists have been able to create a detailed map of the magma chamber beneath Campi Flegrei. This has provided invaluable insights into the geological history of the area, the mechanism of past eruptions, and most importantly, the possible triggers of future eruptions. The drilling project has also revealed the presence of a hydrothermal system beneath the caldera. This is a network of hot water and steam, heated by the underlying magma, which could potentially act as a pressure valve, reducing the risk of a catastrophic eruption. However, the Campi Flegrei Deep Drilling Project is not just about understanding the volcano. It's also about preparing for a potential eruption. The data gathered through this project is being used to develop and refine models of volcanic activity, which are crucial for early warning systems. Indeed, the Campi Flegrei Deep Drilling Project is a testament to human ingenuity and determination in the face of nature's formidable power. It stands as a beacon of hope, a symbol of our relentless pursuit of knowledge, and our undying spirit to protect our home and our future. This project is vital in helping us understand and prepare for what Campi Flegrei might unleash. The future of Campi Flegrei. So, what does the future hold for Campi Flegrei? As we look ahead, it's essential to understand the potential implications of a future eruption. An eruption of Campi Flegrei would not only reshape the geographical landscape, but also bring about significant economic and environmental impacts. Imagine entire towns and cities blanketed in ash, air travel disrupted due to volcanic clouds, and the Mediterranean's aquatic life endangered by changes in water chemistry. Economically, the fallout could be staggering, affecting everything from agriculture and tourism to infrastructure and healthcare. But it doesn't stop there. The human impact could be the most profound. An eruption could displace thousands, if not millions of people, leading to a humanitarian crisis of unparalleled proportions. The psychological toll on those affected would be immense, with the loss of homes, livelihoods, and loved ones. However, it's not all doom and gloom. There's a reason we study volcanoes like Campi Flegrei. By understanding their behavior, we can develop early warning systems to alert us to any significant changes that might signal an impending eruption. Preparedness is key. If we know what's coming, we can take steps to protect ourselves and our communities. This could involve everything from establishing evacuation plans to reinforcing buildings to withstand volcanic ash's weight. Scientists are also working tirelessly on projects like the Campi Flegrei Deep Drilling Project. By studying the volcano's past, they hope to gain insights that could help us predict and prepare for its future. The more we know, the better equipped we'll be to respond when the time comes. While we cannot prevent an eruption, acknowledging and addressing the potential implications of a Campi Flegrei eruption can minimize damage and protect lives. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery.